All right, we're going to do our next lesson. We started with Unit 3, Day 1 today, and that was the basics of what the normal model is. Now, what we took it through was going through this 68, 95, 99.7 rule, the percentages, the fact that we have 6 standard deviations, 3 up and 3 down. And then we put it into terms of context, okay, and then answered questions based on that. So where we stopped was this piece right here that says, what do we do with the normal model if I'm asking you about a context value that is not a whole number of standard deviations away? Because we learned, of course, within 1 standard deviation is 68%, 2 standard deviations is 95%, and so on. But what happens if you're not right on a whole number of standard deviations away? So that's where we start today. All right, so what we're going to do, there's some things in here that's an example about Ileana's first quarter grade coming from a different school, and how does that translate to today's. We're going to actually just skip that piece and go right into this idea of what a z-score actually is. So I mentioned standard z-score yesterday. And by the way, this is in your Unit 3 packet on page 8, the bottom of page 8. So we had talked about this thing called a standard z-score. So here we go. So here's the definition of what a z-score actually is. What this says is the z-score is how many standard deviations you are away from the mean. So if your z-score is +1, then you are over here to the right. You are 1 standard deviation above the mean. If your z-score is +2, then you're 2 standard deviations above the mean, and so on. And then, of course, if you are below the mean, you have a negative z-score. And we talked about the -1, -2, -3. So a couple of questions here. What does a z-score of 0 mean? Well, that means that your value is the mean. You are right there at the mean. And then here's what does it mean to have positive z-scores? That means you are above the mean. And negative z-scores, of course, means you are below the mean. All right, so let's continue from there. So that's the basic definition of what this is. So what happens is we have a formula to actually compute this value of how many standard deviations you are away from the mean. So I want to see, what is your value? How far are you away? And then put that in terms of how many standard deviations that is. So mathematically, what does that mean when you want to find how far are you away from something? Well, you want to find that difference between that value. So I want to see how far your context is from the mean, x minus the mean. Okay, and then I want to do that in terms of standard deviations. So that's x minus the mean divided into how many standard deviations it is. So hence, that's how our formula came about of doing this one right here. Our x minus the mean over the standard deviation, where, of course, z is that standardized z-score. X, we talked about yesterday, is that context value. And then mu is our mean, and sigma, which you all love, is the standard deviation. So I have a song that will help you remember that z-score formula so that you can get that standardized value if you have context. How far away is that context from the mean in terms of standard deviations? So I will say in this song, you're only going to be using this first part, the x minus mean over standard deviation, x minus mean over standard deviation. This part here, inverse norm of the area below is the z at that point. Well, those are TI-84 calculator commands, which don't have anymore. Now I have a Desmos thing. So obviously I'm going to have to rewrite this song and rewrite this second part of this song. But here we go. Let's go ahead and listen to that song, and then we're going to put it into action. So here it is, just the first part of it. Here we go.
x minus the mean over the standard deviation. X minus the mean over the standard deviation. Inverse norm of the area below.
Of course, this is the part you
Inverse
won't
norm of the
use.
area below. Inverse norm of the area below is the z at
But
that
get this
spot.
in your head.
X minus the mean over the standard deviation. X minus the mean over the standard deviation.
Okay, and then it does that other part that is insignificant to you now. Doesn't mean anything anymore since we're going Desmos and not TI calculators. So here's what the big deal is. We want to use z-scores if we want to see how far away is something from the mean. So what that allows us to do, and this is huge, that will allow us to compare totally separate concepts to see how do they compare relative to their own type of item. For example, so let's take a look here, and I'm going to cover up the answers here for a second. So this first problem that we have, we've got this situation where we've got your performance on a quiz, okay? So we have this student who performed on the first quiz, we have the mean and was 32 and the standard deviation was 8, okay? So remember how we would type that out? So on that first quiz, we've got, remember our standard notation that we've been working at? So we've got the n of, 32 was the mean, and 8 was the standard deviation, okay? And that student received a 44, so that's the x value. So x equals 44, okay? And so then, of course, that's on the first quiz. All right, and then we have the second quiz. And that is over here, and we have the second quiz. We have it where we have the normal model, and the mean is 28. Oh no, the student receives a 28. So see, that actually means x is 28. So x is 28, okay? But it follows the normal model with a mean of 23 and a standard deviation of 3, okay? So these are different size curves. And if I graphed both of those on Desmos, which maybe I'll do here in a minute, or I may do that in class tomorrow, then we can see this. So let's see which quiz the student performed better on relative to the rest of the class. So let's get the z-score. Let's see how far they are away from the mean. And you know what? I tell you what, let's go ahead and do this in Desmos. Okay, I think it's worth going ahead and looking at. So here we have our first quiz, and here's how we would do this in Desmos. So here's our commands, because you're going to use these later in the lesson. So we're going to do normal dist, D-I-S-T. So normal dist, that stands for normal distribution. Okay, then we're going to put our mean and our standard deviation in. So our first quiz had a mean of 32 and a standard deviation of 8. Okay, so here we go. We had a mean of 32 and a standard deviation of 8. Okay, and so then let's go ahead and I'm going to zoom fit so we can take a look at that. Now, our student had a score of, and so let's go left, because that's going to tell me who that person, the percent that person scored better in. So this student got a 44. Okay, so I'm going to do, what is the x is less than or equal to 44? So that's like saying, what percent of people are you taller than? So that's your percentile. So look here, if I click on this and then I even hit this little copy button, it will put the entire decimal value. So the probability that you have a score that is less than or equal to 44 is 93.32%. So that person is essentially in the 93rd percentile. Okay? Now, what this is not giving you is that standardized z-score. We have a percentile, but we don't have a standardized z-score. Let's go ahead and take a look at the second quiz. So I'm going to come here and click that and hit copy because I want to copy this value. I'm going to move this up here. So we want to do the second quiz, and I'm going to color the second quiz a different color. And so let's see, our second quiz that we had, what were the values there? We had a mean of 23 and a standard deviation of 3. So here we go, 23 with a standard deviation of 3. Okay, so you can see this looks much different here. Okay, if I zoom fit to that curve, then I've got this going on. And here's zoom fit to the other one. So here we have both of them in view. It's kind of weird to see both of them. Okay, but let's see what percentile the student was in on that test or that quiz. The student got a 28. Okay, so let's see what percentile that student got on this curve, less than or equal to a 28. Oh, look at that. So what you cannot tell from the pictures here, you can't tell relatively which one the student did better on. But if I look at the percentages, then that would tell me the percentile the student is in. So that could be one way that... something else I can help with? That could be one way that you state which one the student did better on. Okay, Siri's wanting to ask me some kind of question, and I don't want to have her help me. Okay, so I can tell that on the first quiz, the student was in the 93rd percentile. On the second quiz, the student was in the 95th percentile. So I could compare those relative positions with your percentile, okay? But a more common way that I want you to do is to do a standardized score, because we need to be familiar with this. This standardized score also tells me if we have an outlier or an unusual point, okay? So that's why getting the z-score is not something that I can just say, oh, let's not do it, let's just do percentiles in Desmos. So I want to get a z-score. So that z-score is going to be here's my x of 44, x minus the mean over the standard deviation, x minus the mean over the standard deviation. So the z-score for the first quiz was a 1.5. So the student was 1.5 standard deviations above the average on that quiz. That's what that means. The student was 1.5 standard deviations above his or her peers on that quiz. All right, on the other one, let's do that ones. So here's the second quiz. Here we go. We're going to do the x minus the mean over the standard. The x was 28 and the mean was 23 with the standard deviation of 3. So there's our x minus the mean over the standard deviation, x minus the mean over the standard deviation. Okay, and that is 1.67. So the question is, on which quiz did the student perform better relative to the rest of the class? Well, when we did percentiles here, which one did we say? The second quiz. They were in the 95th percentile, but on the first quiz, they were in the 93rd percentile. So that corresponds to our standardized score here. The student performed better on the second quiz. This is because the student's actual score is more standard deviations above the mean on the second quiz than it was on the first quiz. Okay, so that's the big deal. That's the way we will compare two different kinds of things, whether it's apples and oranges. Here was the first quiz, the second quiz with different grade distributions, okay? That is how you compare. All right, so here's one that you could practice on. So let's let you do that really quickly. So pause this video. I hear Pumpkin and Cookie barking. Oh, I hear them. Okay, maybe I'll bring them in here and let you see them today. So pause this. I'm going to go get Pumpkin and Cookie, and I want you to, this is about husband and wife, figure out what was happening for the male data, and this was the dollars, and their actual money. So this was money that they made per hour or something. And then for the male and the female. But we want to see how did they do relative to their department. And so get a Z-score for both of those right now. Pause while I go get Pumpkin and or Cookie, and then see how that is. All right, get to work. Pause and do that math. I'll be right back. Come here, Pumpkin. Oh my goodness, you silly girl. Okay, come here. Okay, here's our Pumpkin. Okay, Pumpkin. So her birthday was October 1st. Okay, so she's definitely a fall girl. She is now 1 year old, no longer a puppy, although she still acts like one. Okay, see, she hears Cookie barking out there at something. Okay, you go on. All right, let's check your math. Here we go. So here is our husband. His X was $14.6 minus the mean over the standard deviation of his department. He was 1.5. So incidentally, guess what? He's going to be also in that 93rd percentile because he's at that same as that person was on the first quiz. Okay, let's see how the female did, the wife. Oh, interesting. So she actually makes more hourly, a higher hourly rate, okay, $15.75. But she's in a higher paying department, so relative to her department, she's at $1.25 or 1.25 standard deviations above her peers. He is 1.5 standard deviations above his peers. She is 1.25 standard deviations above her peers. So therefore, the husband is actually higher up in his department than she is because, and here's the reason, and here's how you explain that, he is more standard deviations above the mean. All right, so in summary, if you ever have to compare two different things, you can do that with percentiles, okay? But it is better, for now anyway, pretty much until next semester, that we compare their Z-scores. So that's how I want you to handle that, okay? And so I'm going to go ahead and pause on that. This was the end of the day one notes that we didn't complete today. So I want to stop right there before we then go on to the second day of notes. All right.